All right, everybody. This is section 2.2, quadratic functions. So we're going to look at quadratic functions in two forms today, vertex form and standard form. So it says here, for a quadratic in the form f of x equals ax squared plus bx plus c, the y-coordinate of the vertex is the minimum value. So the y-coordinate of the vertex is the minimum value of the function when a is greater than 0 and the max when a is less than 0. So basically, you just see these two charts. When a is greater than 0 here, the y-coordinate is the minimum, the lowest point of the parabola. When a is less than 0, it is the y-coordinate is the maximum or the highest part of the parabola. So the first one we have here is y equals -2 times x minus 3 squared plus 8. So when we look at something, this is going to be in vertex form. So y equals a times x minus h squared plus k. This right here is our h, and this is our k. Together, they make the vertex. So the vertex is h comma k. Since it is in the form x minus h, the h is 3, and the k is 8. So 3, 8. So for the axis of symmetry, the axis of symmetry is equal to the x-coordinate of the vertex. So the x-coordinate of the vertex. So in this case, the x-coordinate of the vertex is 3. So the axis of symmetry is x equals 3. So right away, I'm just going to graph some things. I'm going to put the vertex. So I'm going to go over 3. And I'm actually going to label these by 2. So 2, 4, 6, 8. And then we'll go here. We'll do 1, 2, 3. So over 3, up 8. That is our vertex. Our axis of symmetry is x equals 3. So draw a little axis of symmetry. Now for the y-intercept, in order to find the y-intercept, you're going to evaluate the function at f of 0. So we're going to plug 0 in for x and see what we get for y. So y equals -2 times 0 minus 3 squared plus 8. So that equals 0 minus 3 squared is -2 times -3 squared plus 8. And it actually comes out to, let's see, 3 squared is 9 times -2, -18 plus 8. So that should be -10. So -2, -4, -6, -8, -10. So there is the y-intercept right here. Y-intercept is 0, -10. And again, I got that by doing f of 0. Now for the x-intercepts, you're going to set the function equal to 0. So set equation equal to 0. So for the vertex, you get it right from the equation, h and k. Axis of symmetry is the x-coordinate of the vertex. Oh, I skipped here, the maximum or the minimum. So this is going to be the max because of the a value right here is negative. So this is going to be the highest point in the graph. So our x-intercepts, set the equation equal to 0, -2 times x minus 3 squared plus 8 equals 0. So first thing I'm going to do is I'm going to minus 8 on both sides. Then we're going to have -2 times x minus 3 squared equals -8. We're going to divide by -2, divide by -2. And you're going to get x minus 3 squared equals 4. Square root. Square root. So now I have x minus 3 equals 2, and x minus 3 equals -2. Now I have two equations here because the square root of 4 is 2 and -2, right? Because 2 squared is 4 and -2 squared is 4. So add 3, x equals 5. add 3, add 3, x equals 1. So those are your x-intercepts. So in a coordinate, this would be 5, 0. This would be 1, 0. So I'm going to plot those here. There's 1, 0. There's 5, 0. Now, I'm going to make the rest of the parabola before I shape it. We can kind of get a shape here on this side. Now keep in mind, this is the axis of symmetry. So this point is 3 units away from the axis of symmetry over here. So I'm going to just put it the same distance on this side. 3 units away. And that's how you graph something in vertex form. So again, this is in vertex form. We call it vertex form because you pull the vertex right from the equation. Our domain here is going to be all real numbers, so negative infinity to infinity. And our range is going to go y is less than or equal to 8. You could write it, or we can say negative infinity to 8, because this is the highest. This is the max. So that is the first example. So at this point, pause this and try this example. Find the vertex, axis of symmetry, determine if that's a max or a minimum, y-intercept, x-intercept, domain and range, and graph. Pause the video and try this one. All right, so here's example 2 all filled out. Got the vertex 1, 4. Again, it's not negative 1, 4 because in the equation it's x minus h, so the h value is just 1. So 1, 4. The axis of symmetry is the x-coordinate of the vertex, so that's x equals 1. This is a maximum because there's a negative a value. It means the parabola opens down. So that vertex is going to be the max. So the max is going to be 4. The y-intercept, we do f of 0. We plug 0 in for x to get y. In this case, we got 3, so as a coordinate, that's 0, 3. To find the x-intercept, you set the equation equal to 0 and solve. You should get 2 for this one. Domain, all real numbers, and the range y is less than or equal to 4, or you can write it like this. So that is example 2. All right, example 3, same as the other 2, except I'm going to walk you through this one because it's going to get a little different at the end. So vertex, again, h, k, but remember, in the equation, it's x minus h squared plus k. So the vertex now is negative 3, 1. The axis of symmetry is x equals negative 3. Since the a value is positive, right, there's a positive 1 here, this is going to be a minimum. So I'm going to stop right here and I'm just going to plot those things. So over negative 3, up 1, axis of symmetry. Oops, I'm sorry, that was only 2. All right, so because this is a minimum, the parabola is going to open up. So keep that in mind, that this is going to be the minimum and it's going to open up. So our y-intercept, 0 plus 3 squared again. We're doing f of 0. 0 plus 3 squared plus 1 equals 10. So our y-intercept is 0, 10. So we'll make this 1, 2, 3, 4, 5, 6. So 10 is going to be 7. 10 will be way up here. So there's 10. Now, for the x-intercept, you should notice that for this parabola, if it's going like this here, and then about here, you should notice that there aren't going to be any x-intercepts because the parabola is opening up and the minimum is at 1. But we're still going to solve, and you're going to see why. So x plus 3 squared plus 1 equals 0. Now, again, think about it. Why are there no x-intercepts? Well, there's no real x-intercepts, but there might be some imaginary ones. So I subtracted 1 off each side. Now I'm going to square root. Oh my God, what happens when I square root both sides? I get x plus 3 equals the square root of -1. What did we just learn that the square root of -1 is? It's I, right? Square root of -1 is I from last lesson. So this is going to be equal to plus or minus I. So we're going to have x plus 3 equals I, and then x plus 3 equals -I. So now we're going to subtract 3, x equals -3 plus I, because remember, we write the equations in AI plus B form, and then subtract 3, x equals -3 minus I. And those two are your x-intercepts, and you're not going to plot them again, but those are your imaginary x-intercepts. So for what we're doing, I want you to solve for the x-intercepts, even if you realize that there aren't going to be any real ones, because now that we know imaginary numbers, we're going to be asking you for the imaginary roots. So these are your imaginary roots. So your domain is all real numbers, and your range goes from 1 to infinity, or y is greater than or equal to 1. So that is your example with imaginary roots. All right, so the next form you're going to see is going to be in the form ax squared plus bx plus c. Now, this is not vertex form, and we have to do a little bit more work to get the vertex. So a couple things. Again, the parabola opens up when a is greater than 0 and opens down when a is less than 0. So that's a key fact. The graph is narrower, so this kind of goes back to our transformations that we did when the absolute value of a is greater than 1 and wider when it's less than 1. Right here, where it says the axis of symmetry is x equals negative b over 2a, you might remember from Algebra 1. That is how we're going to get the axis of symmetry, which you're going to hear me say it 1,000 times, is the x coordinate of the vertex. And to get the y coordinate, you plug in the x value. So to get the y coordinate, you plug in the x value, and the y-intercept is c. So we're going to have to do a little work for these examples. But if you need to copy those notes, just pause the video. All right. So we have this equation. Let's start with a couple things. First thing we need to do is determine values of a, b, and c. So a is -1. Remember, y equals ax squared plus bx plus c. So a is -1, b is -2, and c is 1. So for the vertex, for the x coordinate, so I'm going to do it over here. X coordinate of vertex, we're going to use -b over 2a, or really the opposite of b. So the opposite of b right here, the opposite of -2, is going to end up being +2 over 2 times -1, which ends up being 2 over -2, which is -1. So the x coordinate of the vertex is -1. And for the axis of symmetry, it's x equals -1. I'm just going to draw a little divider here. Now for the y coordinate of the vertex. For the y coordinate of the vertex, now you're going to plug -1 back into the function. So -1, opposite of -1 squared, minus 2 times -1, plus 1. So be careful of this negative in the front. -1 squared is 1. And we got the negative. -2 times -1, plus 2, plus 1 So -2, -1 plus 2 is 1, plus 1 equals 2. So this is 1, -1, comma 2. So again, to find the vertex when we're in this form, we do -b over 2a to get the x. Then you plug that number back into the original equation to get y. So let's graph the vertex real quick. Go over 1, up 2, axis of symmetry. This is going to be a maximum because the a is less than 0. The a is -1. It's a maximum, so it's going to open down. The y-intercept is the c value. The y-intercept is the c value. So that is just going to be 0, 1. So we're going to plot that right here. All right, now for the x-intercepts. We have to take our equation, set it equal to 0. -x squared minus 2x plus 1 equals 0. Now, you can try factoring it. This is not factorable, so we are going to use the quadratic formula to get the roots. So again, you can factor it. This one's not going to factor for us. You could also look it up on Desmos, but in a testing situation, you're going to have to use the quadratic formula if you cannot factor it. So let's do that now. -b plus or minus the square root of b squared minus 4ac all over 2a. We know our values for a, b, and c. So opposite of b is opposite of -2 plus or minus the square root of -2 squared. So again, I'm doing the quadratic formula to get the roots, to get the x-intercepts. Minus 4 times -1 times 1 all over 2 times -1. So that's going to equal 2 plus or minus the square root of, let's see, I'm going to pop in the calculator here. 4 minus 4 times -1. Positive 1 should be 8. So your two solutions are 2 plus root 8 over -2 and 2 minus root 8 over -2. And you can throw those in the calculator. So 2 plus root 8 divided by 2 is about -2.4. And then the other one, 2 minus root 8 divided by -2 is about 0.4. So these are your two x-intercepts. So you just kind of estimate. So -2.4 is going to be like here, and 0.4 is going to be like here. And there is your parabola. Our domain, all real numbers. And our range is -infinity. Oops, not a bracket, a parenthesis. -infinity to 2. Or y is less than or equal to -2. So that is how you do it when it is in ax squared plus bx plus c form. So here is the one that I want you to try. Pause the video and do this one on your own. All right, so here's the worked out steps for example 5. This one asks you a little bit different questions. So again, to find the x-coordinate of the vertex, I did -b over 2a, got 2. That's also the same as the axis of symmetry. To get the y value of the vertex, you plug that number back in. That gives you the y. You can plot your vertex to your axis of symmetry. A, in this case, is greater than 0. The 2 is positive, so it's going to open up. So you know that's going to be a minimum. That's going to be the lowest point. The y-intercept is the c value, so that's where I got the 6. No work needed. Domain is all real numbers. Range, y has to be greater than or equal to -2. So you can really get the range without even graphing it if you just look at the y-coordinate of the vertex. This asks you for increasing and decreasing, so a little spiraling. So the function is increasing from -2 to infinity and decreasing from -infinity to 2. This didn't ask for the x-intercepts, but if it did, you could either factor it or do the quadratic formula to get the roots, but I didn't ask for it here. So this is your video for 2.2. Make sure you copied all the problems.